Okay, it's recording. All right. So this is 3.1 radian measure, and here we've got the formula. I've got a little bit of stuff about circles up here. We're just going to talk about this new way of measuring angles in a circle, which is the radian measure. So previously we've only worked with degrees. You know, we got a circle has between 0 and 360 degrees, and I mentioned it before. That's a Babylonian invention. They divided circles into 360 degrees because their numbering system was base 60, like our numbering system is base 10, and 60 times 6 is 360. Their calendar was split into 360 days. It was very natural for them to use that unit, degrees. In reality, that's just an arbitrary kind of measure that we've imposed on this thing, these angles. So today we're going to talk about radians, which is a more natural way of splitting up a circle, or splitting up the angles within a circle. And you're familiar with dealing with pi before. You may or may not know. I imagine you've probably heard it before. Pi comes from this circle. That's where pi is introduced. Probably one of the earlier formulas you learned in regards to geometry was the circumference of a circle. The circumference of a circle is equal to 2 pi r. Yeah, that's just there. The circumference is equal to 2 pi r. In reality, that's how pi was defined. So I just took my formula and I solved it for the circumference. So I divided by the radius, I divided by 2, and I get this definition of pi. So that's how pi is traditionally defined, has defined geometrically. So a way of measuring angles that is related to that is using these radians. And there's not a lot to radians. What a radian is it's the distance along the circumference of a circle that's equal to the radius. So I've got some string here. Actually, it's a piece of wire, but same difference. If I take a piece of wire, a piece of string equal to my radius, or equal to the length of my radius, and I take that same piece and spread it along the circumference of a circle, that little arc, that piece right there, is 1 radian. I want to make a note of where that is, and then get out one of my markers. Oh, let me get a better marker. Okay. So that distance right there, so what I did is I took this length r and I went that distance along the outside of my circle. That cut out an angle, or that traced out an angle, theta, which we would say this is 1 radian right here, in fact. So we've got 1 radian there. That's made from taking our length r and laying it out on the circumference of our circle. So that would be 1 radian. If we took another radian, that would be, if we went that same distance, that's about right there. So that would be, together that makes 2 radians. If I did that one more time, that would bring me almost all the way around. So now we're at 3 radians. Now, 180 degrees, it splits our circle right in half. Would be about there. Right? That remaining little piece is small. It's a little smaller than I've drawn right there. it's still pretty small. That's about, well, it's 0.1415926, blah, blah, blah. It's the remainder between our 3 radians here in pi. So all the way from 0 to 180 degrees, all that added together is pi radians. So from 0 to 180 degrees, that's pi radians. You know, pi is 3.14. Well, we've got our first radian, there's our second radian, there's our third radian. So there's 3 radians right here, and that last part is the 0.1415926, etc. And if we keep on going around our circle, tracing out lengths that are equal to 1 radian, we end up with just over 6 radians. We actually get 2 times pi radians. Okay. We're getting 2 pi times our radius. Radians. I take that back. No. Now I'm confusing myself. I'm getting ahead of myself here. Okay. So we've got 180 degrees is pi radians. And again, if we kept on going around here, if we went around the rest of our circle, that would give us a total of 2 pi radians. Okay. Now, so that's kind of the reasoning behind where this comes from, where radians come from. Again, a single radian is the distance, it's the angle made by moving a distance equal to your radius along the edge of your circle. So taking this whole thing, let me clear this up and start this over. Okay. If this is our circle with radius r, if we took that length r and instead traced it around the circumference of our circle, so that's also length r, and the angle we've traced out is 1 radian. If we kept on making pieces like that all the way around the circle, we end up with 2 pi r radians. So that one section is 1 radian. All these together is 2 pi times whatever our radius is. Radians. Okay. Oh, I messed it up again. It's just 2 pi radians. That r just keeps coming back to bite me. So the number of radians, this is like a degree measure. That actually doesn't depend on our radius. It's always going to be 2 pi radians, just like when we're dealing with degrees, it's always 360 degrees. So that's probably the first thing I would learn about these. 360 degrees is equal to 2 pi radians. If you know that, you can find any of the other angles we've dealt with just by converting, using this conversion factor of 360 degrees and 2 pi. So we've dealt with converting things before. You can get away with just knowing this for all of your conversions you have to do between radians and degrees. So what do I mean by that? Well, we've dealt with unit conversions before. If I want to convert between units, I set up a ratio. So in our case, I can have either 360 degrees divided by 2 pi radians, or 2 pi radians divided by 360 degrees. Or I can do it the other way around. I can have 2 pi radians divided by 360 degrees. So which one would you choose in order to convert something? Well, that will depend what you're trying to convert. So a simple example. Let's say we want to convert 30 degrees to radians. Okay. So what would I do? I want to cancel out my degrees and be left with radians. So I need the conversion factor that has degrees down in the denominator. So this is the one I'm going to choose. 2 pi radians divided by 360 degrees. So that's what I'm going to choose to multiply this by in order to convert it to radians. So I'm multiplying by 2 pi radians divided by 360. If it helps you to do this, remember you can always write a number like 30 degrees. You can write that as being divided by 1. Right. So I've got some stuff in the numerator. I got 30 degrees and 2 pi radians. In my denominator, I've got this 360 degrees. So rather than multiplying 30 times 2 pi, I'm going to go ahead and simplify this 30 and this 360. So I can cancel 30 out of both of those. So that I cancel 30 out of this, I'm left with 1 degree. I cancel 30 out of this, and I'm left with, oh gosh, I don't know, 12, 120, 12. Yeah. Yeah, 12. 12 times 30, 360. And then finally, my degrees. I can cancel that out. So what I'm left with, I'm left with 2 pi radians over 12. I can actually now simplify that as well. 2 and 12, I can cancel a 6 out of each of those. I'm left with pi radians. Oh, sorry, I can cancel a 2 out of both of those. I'm left with pi radians over 6. Or simplifying that, removing all the stuff I don't need, I just have pi over 6. Now it's in radians. Okay. Now, an important thing to notice, you're not going to have radians written out for you. You don't have to write radians. There's a lot of talk in your textbook. You'll probably see this in any other math textbook about radians not being an actual unit. And it's true, they're not a real unit. You don't have to write these. There's just this assumption that we're talking about an angle measure here. So degrees you always have to write this little sign for, but you shouldn't have to write anything like this for radians. You just write pi over 6. As long as the context is there, I guess that's all people need to know you're talking about it. I'll always try to write pi over 6 radians. I probably won't do it all the time. But that's all there is to doing it. I know it probably seemed kind of complicated. I'll do just 1 or 2 more here. Okay, so let's say I want to convert Let's say I want to convert 3 pi to degrees. So they didn't specify, or I didn't specify that this was in radians, but since they're saying we want to convert to degrees, it's kind of assumed that this is in radians. So I've got 2 pi radians. I want to convert that to degrees. Which one of these do I want to use? Well, I want to use this ratio, because when I do that, I'll be left with degrees in the numerator and my radians, even though I didn't write it, even though it's not technically a unit, that would be done with that. That would cancel out. So we've got the 3 pi, and I want to use this ratio. To multiply by. So I want my 2 pi radians in the denominator. And I want my 360 in the numerator. Okay? So, how is this one going to simplify it? Well, my pi's will cancel very nicely. And I could go ahead and do 3 times 360. I always try to do whatever canceling I can first. Like 360, I can divide by 2. 360 divided by 2 is going to be 180. Right? So I cancel out everything from the denominator. In the numerator, I have my 3, I have my 180, I have my degree symbol. So I need 3 times 180 degrees. What is 3 times 180? 300 and 240? That doesn't seem right. $540? Let me see if that makes sense. 3 pi would be 360 degrees plus another 180, 480, 490, 500, 540. Yes, that works out. Okay. So you need to, you may have to brush up on your fractions. I know a lot of people don't like fractions, but these are the only 2 real conversion factors you'll have to deal with for converting between units. You just have to be able to pick out the right one and use it appropriately. In your textbook and in your example, and help me solve this with MyLabs Plus, they've got these things reduced a little bit. I've never used them that way. I take that back. I have used them that way. I'm used to doing it this way because I always start off from this basis, this idea that 2 pi is equal to 360 degrees, and that's how I come up with my ratios. You could simplify these before we do any calculations. Right? We could cancel out the 360 and the 2. We could simplify this to start with. Right? 360 is divisible by 2. So this is the same as 180 divided by just pi radians. Similarly over here, we could simplify the 360 and the 2 and get pi radians over 180 degrees. So those are the conversion factors you'll see in MyMathLab. The reason, again, that I use this 360 equals 2 pi, this one is easier for me to memorize, and I've always been the type to do as little memorization as I can. So if I can get away with only memorizing this one fact, I prefer to do it that way. Okay, so all of the other angles we've got, all of our standard angles, you can either memorize or you can get comfortable with dealing with using these conversion factors. What I normally do is I've got a few of these that, if I sit down and I haven't done trig in a few months or a few years, which is probably likely for most people, what I have to sit down and do is think about it for just a minute to come up with some of my standard angles, and from there I just deal with multiples of those standard angles. So for example, we found 30 degrees a minute ago. (30 degrees is pi over 6. We could just as easily find all the other ones. Doing some similar method. But I like to think of multiples of this 30 degrees. For example, 30 degrees times 2 gives me 60 degrees. So if I take 30 and multiply it by 2, I get 60. The same thing should occur with pi over 6. If I take pi over 6 and multiply it by 2, that should give me the equivalent of 60 degrees. So since this, so let me just do that. So if I take this, multiply it by 2, I should get, I do get 60. It should also hold over here. So 2 times pi over 6. And that will simplify 2 over 6. That simplifies. I'm left with pi over 30. And if you work that out from our conversion factors, you'll see that 60 degrees really is pi over 30. 90 degrees is just what? It's 1, 2, 3 times 30 degrees. So 3 times 30 gives me 90. 3 times pi over 6 should give me 90 as well. Right, that's got to equal 90 as well. And once again, that gives me something that I can simplify really easily, really quickly. 3 and 6, they're both divisible by 3. I can cancel 3 out of each of those, and it leaves me with pi over 2. Okay. Actually, once I have that, it's really easy to find 45. 45 is half of 90. What's half of pi over 2? Well, half of that is just going to be pi over 4. Again, you may need to brush up on your fractions, but when you take a fraction and divide it by some number, it's the same as multiplying your denominator right there by that number you divided by. 2 times 2 gives me 4. Okay, so just a little bit of arithmetic. It's easy to come up with this list of our standard angles and their measures in radians. We keep on going. 180. I already know 180. That's 2 times pi over 2, which is just pi. We could do 270. That's another one of our angles that's right there on our axis. That's 3 times 90. So that should be 3 times pi over 2. That one I don't even have to simplify, so that's nice. 360. Now 360 degrees you should just know, but that's 4 times 90 degrees. And what's 4 times pi over 2? Four times pi over 2. Again, we can cancel that out. Cancel out our 4 and our 2. And we get just 2 pi. So, I mean, just with a little bit of practice, you should be able to come up with these as needed. That way you don't have to sit down and memorize them all. But of course, you know, you're welcome to sit down and memorize a bunch of these angles. But there are a lot of other angles that you probably don't want to memorize. That's easier to do this way. Like, for example, let's see. (135 degrees). That one, yeah, I guess you can convert it that way if you want. says 135. This is 180. What's the difference between 135 and 180? That's 45 degrees. So that means the rest of this has to be 45, 90, 135. That's 3 times 45 degrees. So 135 is equal to 3 times 45 degrees. And 45 degrees is pi over 4. So that's 3 times pi over 4. And there we go. Now I've got that. I didn't have to memorize anything other than my few basic angles. So probably a terrifying discussion for you. What I would say you are probably going to do is start working with these conversion factors, and as you do these homework problems, you'll start to pick up on these standard relationships, these standard conversion factors. Okay. Once you've got that down, then you should be able to find the trig functions of any of those standard angles. Okay. So for example, find the sine of pi over 3 radians. Okay. Now, looking at this, having never done with radians, you may be terrified, but you shouldn't be. Pi over 3. Pi over 3 is 60 degrees. So this is the exact same as asking, what is the sine of 60 degrees? Unfortunately for you, you've got that memorized, right? Sine of 60 degrees, let's see, is square root of 1 to square root of 3 over 2. The sine of pi over 3 is just square root of 3 over 2. So for any one of these, you can find the trig functions of these. Angles and radians just by converting your angle back to degrees and using those values that you memorized for that first set of materials. So there shouldn't be a whole lot new in this section. If you're really confident, if you did well in the first test, if you learned that material really well, this should be a breeze for you. You're dealing with radians. Okay. Anything else I wanted to talk about for these? Yeah, there's some vocabulary I wanted to very quickly go over. That's arc length. Now, the variable your text uses for this is s. And the arc length, that's the distance you've gone along the edge of a circle when you're given a particular angle. So if I give you any angle at all, theta is our standard angle. So I'll draw a circle and I'll cut out an angle from it. Theta. Then that distance right here, this distance along the edge of the circle, is called our arc length. And the variable for that is s. How can you calculate s? Well, if you know that angle and you know your radius, all it is your angle there is just going to be your arc length divided by your radius. So if you wanted to find actually the length, that length right there, and you knew your angle, Well, we could take our formula and we could solve it for the arc length. That's easy enough to do. So if I wanted to find the angle and I knew the arc length and the radius, I could do this calculation. But again, if I wanted to solve it for arc length, I could do that. I multiply by my radius, and that would give me this. Solved for my arc length. So now I can find my arc length given my radius and my angle. Right. I guess also, if you wanted to, you could solve this for the radius. If you know your arc length and you want to, you know your arc length and you know the angle, you could solve for radius by doing what? Just by dividing by this angle. Right, so that would cancel here. Right, so now I've got this solved for the radius. Now I wouldn't, you shouldn't memorize all of these. You should be able to come up with all of these. That's some pretty standard algebra. You should be able to solve a formula for a particular variable. For nothing else, and so you don't have to waste too much time trying to memorize all these different formulas. I mean, there's no reason to memorize them all. You should know the standard relationship and be able to solve it for the appropriate variable. Okay. So just want to make sure we talked about this arc length. And that's really it for 3.1. So if you made it this far, hopefully I didn't throw you off too much, and I'll see you next time.